Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. In this video we're talking about data collection sheets or tally charts. What this video is about is a chart that helps us count things really quickly when we're collecting data. Let's start with the type of problem we've looked at in probability. Colin wants to test whether a dice is fair or biased. What might Colin do? Well, Colin might roll the dice many times as he can, maybe 50, 100, and then he'll record how many 1s, 2s, 3s, 4s, 5s and 6s come up and compare that to the relative frequency of how they come up to the probability of a sixth for each one. Okay, now imagine that Colin got the following results from 60 rolls. He rolled it 60 times, right? Now, if you every time you rolled the dice, you wrote it down like that. That is unmanageable data there. That's really messy. It's hard to do anything with. It would be better as you went along, you used a more efficient form of collecting that data. And that's what a data collection sheet, otherwise known as a tally chart, will do for you. And it will look something like this. You will say the possible results that people will give you, or results that you'll get from your experiment, in this case 1 to 6, and as you get the results, you tally them. So for example, when the first 5 came out, you would put a dash in 5. When when 6 came out 3 times in a row, you would put 1, 2, 3 dashes like that. And so you continue. You'd put a 1, then a 2, a 3 and a 3. So a 1, a 2, a 3 and a 3. And so you would continue. Now remember, with a tally chart, once you get to 4, the next one 5, you don't write 5 here, you write it like that, so you can count in 5s afterwards. So I'm going to continue to finish off this tally chart. And there you go, that there is our tally chart. Now having done that, we always on a tally chart add another column called a frequency column. And what we do in our frequency column is just quickly count up our tallies. 5 and 4 is 9, 5 and 5 and 5 is 15, 5 and 2 is 7, 5 and 4 is 9, 5 and 4 is another 9, and 5 and 5 and 1 is equal to 11. Now we should just double check we haven't made a mistake counting. They should add to obviously 60, and if you add these up, they do indeed add to 60, and we know we've done it right. So there you go, this is a tally chart, and it will always have the possible results in your experiment or survey, a tally to count them as you're doing it, and then a frequency column where you write a number to tell you how many is in each result. Alright, let's do some questions. Okay, first question, pause the video and have a go at this question here. Fill in the tally chart. Okay, this is just simply counting. I'm just going to whiz through this now, double check you got the same answer as me. Okay, and then we fill in the frequencies. 5 and 5 and 2 is 12, 5 and 3 is 8, 5 and 5 is 10, and we've got 3 left over here. In total, if we add these up, we get ourselves equal to 33 results. We should just quickly count these and double check it's 33. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. And we've double checked that we didn't make a mistake, and we are done. Okay, next question. Pause the video, have a go at this. Okay, Colin rolls the dice 50 times. The data collection sheet has collected some of the results, but Colin forgot to record the scores of 6. So the scores of 6, he just got so excited when he got a 6, he forgot to count them up and tally them up. But he does know, remember, that he rolled the dice 50 times. That's crucial. It says fill in the missing gaps in the tally chart. Well, let's count the scores 1 to 5 he didn't forget anything about, so let's count those up. 5 and 3 is 8, 5 and 4 is 9, 4 is left over here, 5 and 5 and 4 is equal to 14, and 5 and 1 is equal to 6 here. Now if you add up these, if you add 8 and 9, that's 17, add another 4 is 21, add 14 is 35, and add the 6 is equal to 41. 1. So that must mean that 9 are left over here. So he must have got 9 sixes. So that would be a tally like this. It would be 5 here and 4 here. And there you go. We have done that question. Okay, next question. Pause the video. Have a go. So Sarah wants to investigate what type of transport people use to get to work. Design a suitable data collection sheet for her to use. So you're often asked to design these. What you do is you design a tally chart. You include as many options as you can think of, and then you tend to put other when when you've done a few. So what you would do is you would say type of transport. So let's just say the options are maybe walk, bus, train, car, and let's just put other as well. Let's put other as an option just in case there are other ways of doing it, like a tram or bicycle or something like that. Then obviously your next column is always your tally and your last column is your frequency. Okay, and if you just draw it out like that, that's all the examiner is looking for, a tally chart like that, and that would enable you to collect the suitable data. You don't have to cover every option, just make sure you've covered a good few, maybe 4 or 5, and you should be fine. Okay, next one, pause the video, have a go at this. So Brian wants to find out the month in which each of the students in this class were born, design a suitable data collection sheet. Again, that means tally chart that Brian could use. So here we're just going to have the 3 columns. The first one's going to be month, then we're going to have a tally, and then we're going to count it up and have a frequency column. This time there are 12 months, so we should list all of them, shouldn't we? We shouldn't have another column, so let's list all of them. And just make sure you've got yourself a nice table format like this. And there you go. That is a suitable data collection sheet that Brian could use to collect his data, and we're done. And that's it for this video. Thanks loads for watching.